Good morning, good afternoon, and good evening, everybody, and welcome to the Voyantic webinar about tool tracking with Brain RFID. I can see attendees still joining in, so let's give a minute or half and then we can start going. Okay, some attendees are still joining, but I believe we can start. I'm Teemu Ainesoja, and I'm Sales Director at Voyantic, and I will be your host in today's webinar. Before we start, a couple of housekeeping items. This webinar will be recorded, and afterwards the recording will be sent, or the link will be sent to all attendees and registered participants. The webinar will last about 1 hour. There is time reserved for questions and answers at the end of the presentations. During the presentations, you can post questions to the Q&A window, so all of you should have this Zoom control, and from there you can find a Q&A window. So you can post questions there and also upvote questions that are most interesting. So in the end, we will answer the questions in the order of how much upvotes they have received. And after the webinar, we're always interested in getting feedback, so you can send emails to marketing@voyantic.com, questions, feedback, comments, ideas about future topics or such. That always helps us moving forward. We have today two expert speakers. We have Bhavik Kakhada from Xerafy and Rajiv Anand from InThing. And first, let's hear a quick introduction about Xerafy and Bhavik.
Hello, everyone. My name is Bhavik Kakhada, and I am the Sales Director with Xerafy Americas. Xerafy is a global leader in designing and producing industrial-grade RFID tags, catering to various industries and applications. Our products are known for its small form factor, ultra durability, and high performance. Tool tracking is one of our most successful and growing applications. And today, I look forward to sharing more information on the same. Thank you.
Thank you, Bhavik. And then Rajiv and InThing.
Hi, I'm Rajiv Anand, CTO of InThing. InThing is a software. We provide a software platform to help improve visibility, productivity, and compliance by leveraging technologies such as RFID, barcode, Bluetooth, GPS, all the different technologies that are involved in location. Our platform has 16 different solutions that provide you real-time operational intelligence in a variety of industries. One of the solutions we focus on, and it's, as Bhavik earlier said, it's a highly growing and very high traction, is tool tracking with RFID. And that's what we're going to go talk about today.
Thanks, Rajiv. And at Voyantic, our mission is to help companies to excel in RFID. So we provide test systems for tag developers, RFID system developers, and tag manufacturers. And these webinars are part of our contribution to the RFID industry, providing knowledge to help making RFID systems to work well. Our agenda today, we will discuss about the tool tracking in general, what are the benefits, what are the challenges, what kinds of pains are being solved with RFID in the tool tracking, testing and documenting the RF quality and performance, what are the tool tracking systems and their features. Let's start with the tool tracking and why it's important. So, Rajiv, please go ahead.
Thank you, Teemu. Tool tracking, amongst all the different variety of physical things that we have visibility on in the industry is one of the most important one. And some of the reasons why it is important are somewhat obvious, such as productivity. You want to keep track of tools and quickly locate them when there's need. You want to do cost management. You have to know tools have what kind of cost, and therefore a higher cost you want to control, and so you have visibility requirement. There's need for maintenance, like preventive maintenance, calibration, and lubrication, and other service management things that happen in the life cycle of such tools and equipment. And then you have requirements on inventory control and compliance, like in terms of safety regulations and stuff. And I would say those are very important, but somewhat obvious. What is not very obvious is in tool tracking, from an angle of safety and compliance is very, very important in certain industry, even higher. For example, we can talk about industries like aviation. In aviation, as you would realize, not a single tool can be left behind on a plane engine because it can have a disastrous consequence. And there's a name for it in this industry called FOD, which essentially translates to foreign object debris, just a term used by that industry to indicate such a situation. If you go to a nuclear, nuclear industry in general, the term is called foreign material exclusions, but it's essentially the same idea that you cannot leave a single tool, however small it is, in the reactor core, for example, right? A very similar thing that you would see this in this picture here, it's very shocking, but globally, 1 in 18,000 patients being operated upon would have an incidence called RSI, which stands for retained surgical instruments, which is again a tool or a part of tool left behind in a surgical site, at a surgical site on a patient. Again, disastrous consequences. Somewhat less, but even equally important things happen in research labs, where you have tools that are calibrated for a specific research project. And if that calibration is not done in time, your research would give you wrong results. So you need to have that calibration completed. But most of the time, the reason the calibration is not completed is because calibration as an exercise is very, very hard when you have a clutter of thousands and thousands of tools around in the facility. How do you locate them in time, right? And so things miss the calibration cycle and therefore run into problem. Somewhat similar situation happens with manufacturing too. In manufacturing lines, you have this equipment, fixture, and tools that are employed for specific lines, a specific work order, or specific workstations. And they need to, first of all, undergo maintenance, but also, in addition, if a tool that is calibrated for a specific workstation for a specific job, if it accidentally moves to a different line, now you have a production defect. So these are some of the areas or use cases where tool tracking is not just an obvious maintenance problem or visibility problem, but it's somewhat very, very amplified because of the compliance rules that exist there. Go next.
Tool management is a challenging process. There are various issues that need to be addressed before putting together a compelling tool tracking system. Let's look at some of the challenges. One of the major challenges is tools getting lost. Not being able to locate tools or tools left behind in the workspace. Or let's take an example in aviation MRO, FOD, which stands for Foreign Object Debris. Tools left behind in the aircraft is dangerous. Ensuring no tools are left behind in the aircraft is an absolute must. The next challenge is there is a large variety of tool types, so many shapes and sizes that needs to be tagged and tracked. Another challenge is the environment. It will be dirty, there will be oil, chemicals, and a lot of metals, which is not easy to work with. And lastly, to track and maintain a large inventory can be a very challenging process. Next. Let's look at some of the use case and how the tool tracking system benefited them. Here we have HAECO, which stands for Hong Kong Aircraft Engineering Company Limited. Hong Kong Aircraft Engineering Company Limited, HAECO, is one of the largest MRO providers globally. They are using an RFID scanner to track RFID tagged tools inside a toolkit before and after the maintenance job. They are tracking 83,000 tools with the help of a tool tracking system, and they are saving 85% of the time in inventory audit and counts. Next. Here you can see a picture of Railway Operation and Maintenance Center. They are using RFID-enabled tool crib to manage tooling inventory. A tool crib will provide real-time tool visibility and inventory count. Missing tools can be identified immediately and alerted to the supervisors. And one can access the crib with an RFID badge, providing information of which tool were removed by whom and for how long. Next. Rajiv, you're on mute.
Sorry, I was just saying, that there was a mismatch in the title, but I got a little confused on medical device versus rail. Anyway, so this use case is it's something that we currently are working on. And so I have intimate knowledge of walking through these lines and looking at the problems that we are solving. The number one problem is financial, which is cost centers. Every line that in a manufacturing facility, you have multiple lines and you have cost centers assigned to each line. If something like an equipment moves from one line to another, it's actually financially a problem because it cannot be allocated correctly in terms of the cost center. We briefly talked about the right tools at the right workstation and why it is very, very important that the tools that are designed for or calibrated for specific line or work order or workstation should exist there. It should not move anywhere else. And then and this is something you have to have some automation in place, is that if that does happen, because human errors do happen, if something moves from one line to another line, that's called alien object or alien tool detection. That detection happens automatically, and then you immediately inform a supervisor or plant supervisor or administrator that, hey, this has happened, go find it and return it back to the right workstation. So these are the problems that you have to solve using technology because there is no other way. And we're going to talk about that technology next.
So from our extensive experience and research, we find RFID is the most suited technology for tool tracking. So why RFID? Why RFID tool tracking system is the most advantageous? Let's talk about some of the benefits of RFID tool tracking system. Asset digitization. So the asset digitization is very, very important. Every tool will be tagged with RFID chip and will have a unique identification. Another great benefit of RFID passive is it's a small form factor, yet excellent read range. And Xerafy is the leading provider of smallest RFID durable tags required to track smallest of the tool types. Automated inventory and batch scanning is an excellent, and I would say one of the biggest benefit of RFID, to be able to automatically scan inventory coming in and out before and after the maintenance job, and to be able to do batch scanning is going to be a very time-saving process. And just not using a tool crib or a tool cabinet, which is a very automated devices which we have today in the industry, but even outside the tool crib and tool cabinets, using a fixed portals or hand scanners can make RFID as the #1 pick by the users. Another very important benefit is the survivability. RFID tags, and especially from Xerafy, are known for their ruggedness and longer lifespan, and making it suitable for such complex environments. So with the above benefits, which significantly reduces the time taken to do tooling, inventory, and counting, it certainly brings down the operation cost and makes it a compelling technology for tool management. Next. So the very first and a very critical step with RFID-based tracking process is to select the right tag for the right tool. Xerafy has designed RFID tags specifically for tool tracking. On the left side, we have the most popular, our smallest and the best performing RFID tags for tracking metal tools, Dash and the Pico family, which consists of Pico On and Pico Mini. Our metal tags are designed such that they utilize the metal surface as an extension of the antenna, which results in a greater performance. On the middle, we have our mid-size tag offering, namely Pico Plus, Nano Plus, and Micro Power. Very rugged and suitable for larger tool types such as power drills and hammers. Lastly, on the right-hand side, we have our tag offering for non-metallic tools, which is not a lot of percentage if you compare the tooling varieties, but still there are a lot of non-metallic tools made out of plastic or other materials. Slim Track and titanium tag from Xerafy have the best performance and the lowest thickness possible for a rugged, durable RFID tag. So it is very, very important to pick the right tag for the right tool to ensure the best performance. Next. Once you pick the right tag, this step is equally important, the tag attachment. Doing this step correctly ensures longer tag lifespan. And we have, over the years, did a lot of work and research behind putting together the best attachment process. The first step here is to apply the base adhesive on the tool. This adhesive would set the foundation and will firmly hold the tag on the tool. The step 2 is to place the tag over the base adhesive and let it cure. Now the next step is to apply an encapsulation epoxy over the tag. This process is equally important because this secures the tag to the tool and provides protection not only to the tag but also to the base adhesive, and also protects the tag from, let's say, any collision or dropping, which will happen very commonly in the tooling industry. And lastly, applying a heat shrink tubing. This completely seals the tag and also the adhesive and the encapsulation epoxy and protects it from being contaminated due to oil, moisture, dirt, or any other external factors. So attachment of the tag for the longer lifespan is very, very important. And this process can be simplified if you have a very nice production setup. Next. We talk about the attachment, we talk about picking the right tag. Another major and very important step is to ensure the tag is oriented correctly and is positioned correctly. So we can select any tags, right? We can select the best tag, let's say. But if it's not positioned correctly, if it's not oriented correctly, you will not get the best results and tracking consistency. So this, positioning of the tag and the orientation is technically the most important step. Let's play a quick video showing how the tag is aligned with the tool. So you can see here, the tag is aligned in parallel and along the length of the tool. This way, the tag is utilizing the shape and the longer side of the metal tool, which helps generate greater performance. We must also understand and ensure that the tag is positioned in a safe spot, such that it doesn't interfere with the operation of the tools. Otherwise, the tag can be damaged. So when we are deciding on the tag position and the tag orientation, we have to understand that there is a certain best practice which leads to the best performance and the best results. And following that will ensure you tracking consistency. You will be also able to tune your reader setup based on the consistency of the tags if it's aligned correctly in each of the tools. Next.
We got a couple of questions about the effect of the heat shrink and the epoxy encapsulation, whether they affect the tuning and the read range. So I assume that that's something that you need to take into account. So something that can be handled. But any comments about those?
Absolutely. So the tags are very durable and high heat resistance already. So the heat shrink tubing is not going to affect the tag durability or performance at all. And also the applying of encapsulation epoxy or the heat shrink tubing is already considered into the design. So that effect is already nullified at the time these tags are designed and tuned. So once you apply the heat shrink tubing and the epoxy, you will still continue to observe the best performance based on how it has been tuned prior to that.
Thanks.
So here are some of the pictures of the RFID tag tools. As you can see, in some of the pictures we have applied the heat shrink tubing. The one picture on the left-hand side bottom, it's still not complete, but we wanted to just give you an idea of how the tag is oriented here. It's aligned along the length of the tool, and that makes it the best orientation, giving the best performance possible. Next. So far, we have discussed how we can tag retrofit existing inventory. But the question is, what about the new tools? What about the future of tool tagging? Can we have a process where we don't have to do any tag attachment? And the answer is yes. Xerafy has designed a solution where a RFID tag is integrated into the tools at the point of manufacturing. We call it connected tools. And even the most challenging tool types, the sockets, are designed with our RFID integrated solution. This is a revolutionary innovation in the field of RFID tool tagging. It saves tremendous amount of time that goes behind attaching or retrofitting each tool. And at the same time, the tools are smart RFID enabled, ready to go and ready to be tracked immediately once out of the production. So this technology today is in offering by Xerafy, and we believe that this is definitely the future of RFID tool tracking and tool tagging.
Thank you, Pavik. Next, few words about the testing of the RainTag RFID tools, both in R&D and then when things are moved into volume production, how to make sure that each tool works well. First, if we start with the RF performance testing, which is very similar actually to RFID tag testing, some of you may be familiar with. So the tool is placed to test chamber so that the tag is in the position and orientation of the reference tag. I don't go into details, but the ones who are familiar with the RFID tag testing know the process quite well. The red RF-friendly foams you saw in the video, they were for adjusting the height or for the thickness of the tool to be tested so that the tag is in the right position. First test in the characterization is threshold sweep. This tells about the read range which is achievable with the tool, as well as about the tuning of the tag used in the tool. And in this case, it is very clear that this tool is designed to be used in geographical areas where RFID frequency is from 902 to 928 megahertz, so-called FCC band. At the FCC band, the achievable read range with this tool is over 10 meters, whereas at the lower LC band, the read range is limited to about 3 meters. Next, we will check the orientation sensitivity of the tag tool. This test tells how well the tool can be read from different angles. We can see that the tool can be read well when the tool's long side faces the antenna. But when the tool's end points to the antenna, the read range drops dramatically. The tool is not symmetrical. So for getting a better view of the readability, we turn the tool and repeat the orientation sensitivity test a couple of times. For example, we want to see how well the tool can be read when the tool's body is in between the tag and the antenna. There was a question in the Q&A window about how can we make sure that the tag would work in when it's used on both sides. So I believe this test is sort of answering to that question. So it would be part of the test process to make sure that the RFID tag can be read well enough in different orientations, even if the tool itself is between the reader and the tag. So after repeating the orientation test 3 times in this case, we have a good full picture of the readability. So in general, in this case, the tool can be easily read when the long edge of the tool faces the reader, regardless of whether the tag points to the reader or if the tool's body is in between the tag and the reader antenna. But when the narrow end of the tool points to the antenna, the read range drops to very short range. Next, for providing easy information for brain RFID system designers, tag tool users, we also conduct the tagged item grading test for the tool. This test tells which tagged item grades the tool passes, and these grades refer to GS1 standard for tagged item performance. I don't go through the details of this standard on the purpose, but it's very well applicable to tools, and it eases the communication about the tool performance. So the grade is an easy communication tool to any system designer, tool cabinet manufacturer, or any company using the RFID tag tools. Once they know which grades their current tools pass, it is easy to request any new tool to pass the same grades. And with the grading, any tag tool user can certainly know that the new tool would work well in the RAIN RFID system or cabinet. The tagged item grading is an easier way to communicate the performance than request certain tuning and orientation patterns. And in this case, the tool passes single item grades S20B, S15B, and lower grades. We didn't test multi-item grades in this case. The performance of the RAIN RFID tag tool should also be documented, and the RF performance should be communicated to tool users and buyers. And in my opinion, the RF performance information should be part of the tool's datasheet. It is quite a natural way to communicate any details of the tool, including the RF performance. Information of the tag tool's RF performance, it's actually very similar to RFID tags performance information. So tuning, the orientation patterns, and past GS1 tagged item grades would be quite good pieces of information about the RFID tagged tool. Testing and documenting the RF performance is important because all tag tools don't automatically have the same performance. Pavik talked about the importance of correct orientation and importance of selecting the correct tag for each tool. So here's an example where same tag were used in two very different tools. And the result, you can see that they are very different. So the readability, read ranges are very different, orientation patterns are completely different. And it would be very difficult to design a well-performing system when tag tools perform in very different ways. Without visibility to how the tools work, just relying on luck on tag selection and tag placement, some tools just would not work well. And this would create problems in use. It would be easy to miss these tools, among others, for example, in a cabinet or a toolbox you saw earlier in the presentation. So, and that would obviously lead into errors in inventory counts or create other exception actions in the processes. Also, in manufacturing, we should have some testing process. So when the tag tools are manufactured in volumes, the quality should be tested. Any error in tag placement, tag mounting, any of those could lead into lower RF performance. And we can capture those in a production testing before they cause problems in use. Depending on the production volumes and processes, the testing could be manual, where a person moves the tool one at a time to top of the coupling element and makes the quality check, or the coupling element you see in the video at the bottom could be installed into a production line, and the tools would just slide over the coupling element with some speed. So depending on the volumes and the state of the production, the quality testing can be done one at a time or in automated process. Next, let's take a look at the tool tracking systems.
I'll take that. So we talked about RFID tags and their importance of them being the right kind, and also the importance of being them attached to the tools in the right way. And of course, as Bhavik shared, in future, we'll hopefully have most tools pre-tagged before they even arrive at customer location. But the number one thing that comes after that, after the RFID tags are on the tools, is that how do we track them? We need a software, a system that does various operations that you currently manually done or using barcode. You need to migrate to a different system that can automate a lot of things. And what do we need? We need data management. So the way of when you attach or enroll an item, a tool, into the system, there should be a way of doing that easily using different methods. There should be a way of replacing tags if we need to. We need to be able to manage tools and also toolboxes and kits, and in case of healthcare, maybe a surgical instrument sets. They need to be maintained in certain ways, because in some of the industries, you create a toolbox for a specific purpose, and that purpose requires that you have 4 wrenches of this kind, and then 3 hammers of that kind, and so that configuration is important to be managed. And so when the assembly of that toolbox is done, when it is disassembled, the calibration, service management is done, and it ends back in that toolbox, there should be a way of figuring that out, that it is correct. And so auditing process and all of these things is something that is packaged into a software. And in software is not just a software as in one piece of software, but it requires multiple components. We are talking about one component that would allow you to do all of this data management, and then performing things like calibration. So when you do a calibration, what should happen? Maybe the system should alert you that, by the way, this tool at this location is upcoming for calibration. And that kind of information is really very helpful, because that's when somebody can organize a calibration cycle and go out there and then complete that. There are other areas like, and I think we can go to the next slide, where you would need to do not just data management, but this is now operational. Can we go to the next slide? So operations are, for example, you walk into a stock room and you pick few tools for your purpose as a technician. You could be picking up toolbox, you could be picking up very highly specialized tools from a crib or from a cabinet. All of this is now automated. Thanks to RFID, everything is being watched all the time. So when you perform a checkout, system knows exactly what you have taken out, and it's expecting them in return at a certain time frame. You take a tool, as Bhavik was explaining in one of the use cases, you go to a tool crib and you pick out some tools. The tool crib knows who it is, what they took, at what time. And all of this visibility is really important, because this is how you provide 100% accuracy of tools being in the right place at the right time, and making sure some of those compliance or safety issues that we were talking about, or the cost issues that we were talking about, is addressed. So these are, excuse me, these are fixed stations, right? And self-service kiosk that allows people or technicians and operators to be able to interact with tools by themselves, and there is no administrator required. Sometimes you also need some kind of a field-based, next slide, Tim, field-based tools, and for that you have mobile. And then mobile allows you to, like these days, you have RFID and barcode integrated into an industrial handheld. And these industrial handhelds are capable of reading RFID tags, and therefore the tools, from a distance like 5-10 meters if you need to. And that allows you to perform, let's say, a cycle count or an inventory in a stock room that would normally take days into minutes, literally. I mean, less than an hour, you can complete a 20,000 square foot stock room. You can perform audit based on location, like this location at the field service station, I'm expecting these tools. Perform an audit and see if there's anything new that's not expected to be there, and alert you, and you can locate that particular tool using Geiger counter, which is another functionality that everybody loves, is because when you're dealing with tools, you're always dealing with clutter, right? Unless it's in the stock room, it's always all over the place. How do you find something if you need to find it? So this handheld will allow you punch in the tool that you were looking for, and it says, okay, let's go and find it, and starts beeping as it gets close to the items. That's very useful, especially when the items tools are hidden and they are small. Performing, those assemblies that we were talking about, like making a toolbox and then auditing that tool. All of this can be done in a field thanks to a handheld that is capable of doing all of that. In addition to tools, sometimes also come with consumables like things like oils and gauges and all of that stuff. You can track them too using the same exact technology. Using labels and cheap RFID tags, you can track all sorts of consumables as well. So these systems, the self-service kiosk, the mobile, and a data management platform that is available, right out the box, is something that is really, really necessary for making your tool tracking system journey somewhat seamless.
Thank you. That concludes the presentation, and we have plenty of questions to go through. I can see that the most upvoted question is that how does Teemu stay looking so young? I think it's because of touch your appearance functionality in the Zoom. So thank you, Jack. There are a few questions about locating. So using the tags in a RFID real-time location system and the accuracy of the location specifically, can we go down to 1 centimeter accuracy?
So there was a question about the RTLS. I think I can take that because RTLS, for people who don't know what that is real-time location system. And that RFID technology is in fact very ideally suited for RTLS system. And again, this is locating items in real time and in an automated manner where the visibility of the tools and our items are all the time, 100% of the time available. And that is absolutely possible. We have used that, and RTLS system is actually in play in a lot of manufacturing places where work in process kind of use case is there, and you want to track which tool is where. So yes, the answer is yes.
Any comment about the accuracy? Is it possible to get to 1 centimeter, or what kind of locating accuracy would be reasonable to expect?
I'll just take that one. Actually, there's a combination of questions related to the success of tag tools stacked together, whether it's in a toolkit or in the cabinet. So if you have tag tools inside a cabinet or inside a crib, they're already having a lot of antenna power within a box, like a Faraday cage. So the percentage is going to be 100%. Now, there is always going to be a limit of the number of items you can stack inside a cabinet. Depending on the size of the cabinet and the space, you can allow, a specific quantities. But once you have that much quantities inside the cabinet or a crib, the accuracy has to be 100% because of the way it's designed. If I had one question that I've seen, and that was, I think, on, if the tags are in a toolkit inside a toolbox. And I know, Teemu, you're also looking to answer that one. But I think the feedback on that one is you have tags already placed inside the toolbox. There is still a lot of metal. The signal tends to bounce back and forth. We have seen consistent reading results in a toolbox with the metal tools and tag stacked next to each other, very close to each other. Certainly, there is always going to be a limit. You have to keep that in mind that there is so much metal around. These technologies do tend to get affected with a little bit of extra metal. So, but from our expertise and from our experiences, we have seen toolkits with up to 50 tags, tools consistently being read, and even more in some cases. But it does depend on how the layout is or how what kind of reader structure you're using, what kind of scanner you're using, what is the surrounding environment as well. And I think when you have, so RFID, I think the biggest benefit of RFID, I would say, as compared to other technologies, there is NFC out there, which I heard a question about NFC. The NFC is a close range. We know it's a very short range touch distance. The benefit about RFID is you can have tags that can read really far. At the same time, when you have a right antenna setup, when you have a reader that can trim down or tune down the reader antenna power, you can read tags at a very close distance, so you can avoid cross reading. So this is a very, very important benefit of RFID, where you can go far or you can get closer to read only one tag, even if there are surrounding tags around it. 1 centimeter is slightly tighter because by the nature of the RFID antennas, you don't have antennas that can be really small, but it can definitely come down to very, very close range if you have the right reader and antenna setup.
Thanks. I could continue about the box reading. So I think there are two slightly different applications. So this kind of toolbox where the tools are not organized, having 100% read range every single time probably is not the expectations, but when it's good enough and the system gives you the exceptions, it's quite easy to shake the box a little bit and get to the 100% if your system shows that you're missing one, or sort of manually check what is the missing one. I think the way to get to 100% is to have these home organized things where the sort of readability of the tool positioning can be optimized. So there are ways to get to 100%, but you can get close to 100% even in these, let's say, non-organized toolboxes, but having 100% every time, probably not the exception, but good enough for any practical application. So the exceptions can be handled well enough.
Yeah, I see one question here on the RFID cabinet being completely metal. If the RFID cabinet is built with metal inside, it actually does help with the performance. The signal tends to bounce with the metal inside, so there is a higher chance of reading tags more consistently and even in more quantities. We have cabinets out there today in the industry which are made out of metal, and there are some that are made out of plastic as well. The important factor with the cabinets is it should not be able to, it should be protecting the signal to go outside or any outer signal to come inside. That's going to be the most important thing.
I see a question from Lance. Have you ever done testing with canvas bag carrying glue stools? Yes, this is actually a pretty common use case where you are walking through a portal and you have a bag of tools or anything else, consumables, items of various kind. And the portal portal reads everything and then accounts. In fact, you can go further and have the person who is carrying this also recorded, because the person would have a badge with an RFID tag and you would recognize who is carrying these sets of items. And thanks to complexity of software these days that we do, we have also done things like, if a person is going one side of the portal and the other person is walking the other way, you can account all the tools and the people correctly using pattern recognition. Good question.
Thanks. There's been a couple of questions specifically about surgical tools, and about the tools and the tags surviving the autoclave process. So I could mention that we had a webinar earlier, a year ago maybe, specifically about medical instrument tracking. And there is, if you scroll down the answered questions somewhere, there is a link posted by Voyantic Marketing to that previous webinar. It discusses the details about the surgical instrument tracking.
And just to add to what Teemu said, I saw a question about best practice if the tags can survive ultrasonic sterilization, I believe, or cleaning. Yes, the tags today are used in the medical industry, but with the right encapsulation, having to use an autoclave resistant epoxy or material is important to protect the tag for the long run, and also for having the tag stay on the tool instruments, I would say medical instruments, as long as possible. So yes, today there is RFID tag tools, RFID tags from Xerafy used in the medical industry. One question I've seen here is, when designing tags for tools, on which do you put higher priority between maximizing average and minimizing variance of read range? Jerry, the answer is you need to find the balance. You want to have the maximum range for sure, but at the same time, you want to have very minimum variance. I think Xerafy has been very, very cautious, and when we design our products, we pick the best material which allows you with the very, very minimum variance in the read range. So it kind of brings the production consistency to a high level, very, very highest level, I would say. So yes, when we design the tag, our first focus is the tag has to have the best reading performance, and the production team and our engineers together will pick the right material and the production setup. So there is absolutely very limited variance in the read range between one tag to other.
There is also a question about the read success percentage of tools stacked in RFID-enabled cabinet. So I believe this refers to this kind of tool grip. I'm assuming that we can quite reliably get 100% read ranges, but any comment from Bhavik or Rajiv?
Yeah, the whole idea of an RFID cabinet, because it's enclosed, the whole idea is to have 100% success. But with any hardware and technology, there is always going to be a threshold. Like I said, depending on the size of the cabinet, it can allow only a certain amount of tools or quantities inside it. So once we have met that requirement, yes, the whole concept behind the crib and the cabinet is to have 100% accuracy and consistency, because it's going to be the most important factor when picking a right cabinet or a right crib into your tool management system. Having 100% consistency is the key with some of these hardware solutions.
Thanks. There's also a question about the tags working when there are several tags or I guess tools close together. I think we've discussed that a little bit in regards to cabinets. I would add that there are tag designs. So some tags are more sensitive to effects or disturbance of a nearby tags, and then other tag designs are fairly immune to nearby tags. So it comes down to the tag selection also on that part, and it has to fit the single tool, but also how the tools are then carried in a cabinet or stored in a cabinet. There is a question about the orientation pattern, orientation sensitivity plot. That there is a question from Christopher. So I know that there is a very distant void, for example, on the ratchet. It appears to have that the void focused on the head of the tool. But if tools are hanging on a board with an antenna overhead, wouldn't we have issues reading tags directly? And yes, so if we have a tag and tool performance like the one in the red chart, the read range drops very close to zero when the tool is pointing, the narrow edge is pointing to the antenna. So it would be a problem. But again, with the correct tag selection, that could be fixed. Of course, if the tool is used in multiple different applications, I think that's the hardest. For example, this other orientation pattern with the sort of 4 loops going into different directions, the longest read ranges may not be as good as with the more typical typal design, but it creates smaller voids. So again, it comes down to the tag position and tag selection and those matching how the tool is planned to be used.
I'll take one question from Bhavesh Joshi. He asked, when tools are not tagged with RFID, they are counted by hand and no issue. In that, however, when we have RFID tags attached to the tool, we scan it with the reader, we trust the reader, the system. Sometimes they are not read and hence an error. How to resolve this? Bhavesh, I think good question. I think the first part of your question is when the tags are not attached to the tools and they're being hand counted. We have seen and we have heard this from our actual users that they do make a lot of errors even with manual counting because it can be a very long and challenging process. So we have seen issues, and that's one of the reasons why they are trying to get a system in place which can be more automated and more trusted. So when you have a system in place with RFID, you are creating the best setup possible and you are repeating and doing the consistency testing to ensure that there is a very high level of consistency anytime you're making or doing the tag counting, whether it's checking in, checking out. Once you have that consistency and a system that is very robust, you will trust the system blindly, and that's the whole process of having a RFID-based automated system where you don't have to worry about manual counting or errors by human. The system is designed and tuned to give you the best results every time.
We are coming close to the end of the reserved time. I think we can take a question or two.
I'll do one question from Robot. If you have a bag of tool compared to a box drawer, yes, with tools, you should expect different readings. So there would not be 100% reading in the tools, not to be night placed in a drawer, right? If I understand your question correctly, yes, the first answer is if you have a bag of tool as compared to inside a drawer, there is going to be a challenge there's going to be a different reading setup, right? In the drawer, it's already set up in a way it's going to give you the best reading consistency. When it's in a bag of tools, which is still, I'm guessing, inside the drawer, it's still going to give you the consistency because a plastic bag would not affect the read range, especially inside the drawer, to an extent where it will not give you the consistent performance. The tags are already designed and tuned with any layer of epoxy or heat shrink tubing. So even a slight layer of plastic packaging or bag would not affect the read distance or the reading consistency of the tags. So yes, you should be okay with going ahead and using a bag of tools inside a drawer or even on the outer side, having the right reader portals and tuning it to make sure that the batch tool is always consistently being read will be the key in your consistent performance.
And I think that also comes down to the system information and how it's configured for the use case. So if you have this fixed drawer or container, and for example, we have a sign out or checkout process where someone logs into the container, picks 20 pieces of tools to a carry-on container, whether it's a plastic bag or a full container. And then at the site, the contents of that tool bag would be read with a handheld reader. There is the background data that these 20 tools are supposed to be there. If you only find 19, then the correction is quite easy. You shake the bag, check if you find all 20. If you still find 19, then you start to go into an exception process and start to figuring out, are all of the 20 tools really in the back, or did I leave something out? So it's a combination of the process, and I would say that the RFID works well enough for these systems to work well, even if the read in every single situation wouldn't be 100%. And the most challenging ones are these sort of mesh of tools in a random orientation into a toolbox, or that's a challenging read condition. But it works well enough for the system to work very well.
There was a question about what type of software is used to keep track of the tools. I would request you to, if you can go through the recording of this webinar, we already discussed the software piece.
Yes. And also there will be contact details of the presenters afterwards in the email you sent. So I can see that there are questions about resales of the InThing software and so on. So please feel free to continue those discussions then afterwards. Our time is full, so I will end the webinar and thank Bhavik, Rajiv for the presentations and expertise, and everyone in the audience for taking the time to attend to this webinar. Thank you very much, and you will be receiving the link to the recording shortly. Thank you.
Thank you, everyone.